Okay, so this is AP Calculus BC, the lesson for Chapter 3, Objective 1, and we will be going over critical numbers and extrema. So we're going to start with just the definition of a critical number. So DFN is definition, and I tend to do a lot of abbreviating since we are not doing the student guided notes. Okay, so definition of a critical number. So we're going to start with a function, so we're going to let f of x, or let f be defined at some value of x that will be c. So we tend to use c for a particular value of x. So let f be defined at c. And so if the derivative when evaluated at c is equal to 0, or if f is not differentiable, at c, then c is a critical number of f. Okay, so I'll give you guys a second to catch up with that, or you can press pause too as well, like that will work also. Okay, so just to kind of clarify, because this f is not differentiable piece, sometimes that can be kind of confusing. So when we're working with the derivative itself, so if we have like what f prime actually is, then that just means that c would not be in the domain of f prime, okay? So c would not be in the domain of f prime, okay? So in the domain of f perhaps, but certainly not in the domain of f prime. So that means that part is not differentiable. So that would be if given the function, right? So given f prime or working with f prime. The other one that we would look at if we were looking at the graph, so specifically the graph, we would be looking for sharp turns, you know, of f, okay? So that would be the not differentiable component, right? So two things to look at. So if we have f prime itself, right, f prime itself, then c would not be in the domain of f prime, so it would not be differentiable there. Provided it's in the domain of f. And then your sharp turns of f, right? So sharp terms of f, it would not be differentiable, okay? So then what are we looking for the f prime of c equaling 0? So f prime of c equaling 0. Well, given f prime, we would equal it to 0 and typically use, you know, 0 product property or something like that. But in terms of the graph itself, we're looking for hills and valleys, so like your relative maxes and mins, right, of your graph of f prime, right, graph of f prime. Okay, so we're going to do a graphical one first, just to kind of get that sense, and then we'll do some algebraic ones as well, okay? So for our first example, we're going to be looking for the critical numbers of f. So find the critical numbers of f of x. Okay, and so our first example will be working off of a graph. Slide that up a little bit. Okay, so I'm going to draw a graph here. It's going to be kind of a negative quadratic to start with, so I'm just going to start over here at 2, and I'm going to cut through at -2. And then up on the y at +2. Okay, so I'm going to start with these 3 dots right here. And I'm going to do a negative parabola that goes through those 3 dots but does not extend past the 2, so pretend that's a smooth curve. Okay, and then it's going to shoot up and off, so it's going to be like a sharp turn right here. And again, this is f of x is what we have, so f of x. So again, what are we looking for? So we're trying to find the critical numbers of f of x. So we have a graph. So we're looking for, so in order for us to have a critical number, remember the two things that we're looking for. So we're looking for relative maxes and mins, right, because we have the graph. So we're looking for hills and valleys, so relative maxes and mins. And we're looking for sharp turns. That's an A, even though it doesn't look like, right? So why am I looking for those two things? Because I have a picture, right? I have a picture of a graph. And so if I look at this, I have two locations, right? I have two spots where I have a critical number, right? So I have this spot right here, because if I were to look at the tangent line here, I would have a horizontal tangent line and the slope of that, so m with a subscript of t, so the slope of the tangent would be 0. And then right here, this would not have a slope of 0. This slope would be undefined, right? The slope of tangent would be undefined, so f would not be differentiable there because I do have that sharp turn. Okay. So where are my critical numbers? So my critical numbers would be at x equals 0 and 2. Okay, x equals 0 and 2. All right, so that would be just kind of a graphical component. Let's take a look at algebraic. So we'll do an algebraic one here. So same directions. So we have f of x is equal to x cubed over 3 and then minus x. So I'm going to just do the steps off to the side over here. So the first thing I would do is I would want to find f prime of x, right? Because I want to look to see where the slope's equal to 0 or perhaps where it's undefined, right? So my first step is to find f prime of x. So I'm going to rewrite this right here because I don't want to look at this and think, oh, I should be doing quotient rule, which I would not, right? Because I don't have a variable in the denominator. So I'm just going to rewrite it. I'm not taking the derivative right now. So I'm going to rewrite it as 1/3 x cubed minus x to the first. And then that way we have, so we see it as a coefficient. Okay. So then now I'm going to go ahead and take that derivative. So I would do 3 times 1/3, which would be 1, and then reduce the power by 1. And then this would be minus 1x to the 0, which would just be 1. So then once I find that derivative, then I'm going to look for places where f prime might be undefined. So what are the values that are not in the domain, right? So find where f prime is undefined and also where f prime is equal to 0. So when I look here, it would be defined everywhere because there's no variable in the denominator. That's usually the most common thing you would look for. So I don't have a variable in the denominator, so there would be no place where it's undefined, which is good. Okay, and so then I'm just going to set it equal to 0 and then solve for x. Okay, so you can factor it, you can add 1 over square root it, whatever it is that you're most comfortable with. I'm just going to factor it and use 0 product property. So then I would have two values of x here, so I'd have x is equal to -1 and 1. And then that would be where my critical numbers are. Okay. So I have critical numbers at -1 and 1. Okay, let's do one more here. Okay, so this would be C. So we have f of x is equal to x over x plus 1. Okay, so then right off the bat, I should look at my domain here because I don't want to confuse that with a potential critical number. Okay, so if I look at this, I would say, okay, so right off the bat, x cannot equal -1, right? Because if it were equal to -1, that would be undefined in the denominator, right? So that would be undefined in the denominator. So -1 is not even in the domain of f. Okay. All right, so let's go ahead and find the critical number. So we would do quotient rule. So I'm going to do low d high minus high d low all over the square of what's below. So low, and then d high minus high d low all over the square of what's below. Okay, so low, so x plus 1, and then d high, so the derivative of x would be 1x to the 0, which would just be 1. Minus high, so x, and then d low, so that would be 1x to the 0, which is just 1, and then derivative of constant is 0, and then all over the square of what's below. And not that I have to simplify, but I'm going to go ahead and simplify this just a little bit here. So I'm going to go ahead and multiply in that 1, so x plus 1, and then minus x. And then I would combine like terms, so x minus x is just going to cancel, so then I would have f prime is equal to 1 over x plus 1 and then squared. So I've found the derivative, and so I look for two things, right? Where f prime, right? So two things I'm looking for. Where is f prime undefined? And where f prime is equal to 0. So if I look at this, f prime is undefined, right? So f prime is undefined at x equals -1, right? But that is not a critical number because your critical numbers must be in the domain of f of x, must be in the domain of f of x. So if x were -1 up here, it's undefined, right? And so that cannot be a critical number. So even though it's undefined there, it is not a critical number. And then the second thing I do is I set it equal to 0, right? So x plus 1 squared is equal to 0. So if I think about, okay, well, how will I solve this? Well, the only way for a fraction to be equal to 0, right? The only way for this to equal 0 is if a is equal to 0, but not b, right? Or whatever the function is. So that's the only way for a fraction to equal 0. So if b was 0, then that would be undefined. If they were both 0, that would be indeterminate, right? So the only way for a fraction to equal 0 is if the numerator is 0. Well, the numerator is not 0, it's 1, right? So then this would have no solution here also, right? So our conclusion then would be there would be no critical numbers. So therefore, no critical numbers, okay? All right, and then there is absolute extrema that we have as well. And so we're going to take a look at absolute extrema because they come up again in objective 3, which is mostly how we use them, or relative extrema, excuse me. And so when you look at this component, we have something, you know, that, or in this lesson, there's absolute extrema as well, or in this objective, but we cover that again when we get into 3.3, okay? And that is that.